My name's Briscoe. I'm cute and I love math. And y'all better do well on your test tomorrow or the next day or whatever. Stop licking me. Come on, focus for the adults. Focus for the kids. Y'all better do good on your test tomorrow or you're going to get it. You hear me? I mean it. All right, buddy, go down. Go. Thanks, buddy. I know. Bring the dog back. The dog's cute. Yeah, that's my boy. That's my big boy. He is kind of cute. Anyway, hey, we got to focus. Okay, so I figured I'd make a quick video on how to do these problems. Hopefully I can do this rather quickly. I'm not sure how long it's going to take. If you know how to do the problem, skip it. If you don't, and you haven't tried it on your own, try them on your own, okay? So we're going to go through quickly. You got to do 3, but I'm going to do them all. Again, yeah, Monday, April 1st, 12 p.m. I don't know. Maybe I should say 12 a.m. Anyway, I should learn to just say midnight. Anyway, let's get started on this. So here's what we got. Remember what I told you before, right? We're going to follow this flow chart. All right. And I think on this problem, what you're going to find out is there's an OR. We have an OR. Let me highlight that OR. Oh, I don't want you. I'm going to highlight that OR. That OR is right here. Now, I don't care what else is going on in the problem. Let's figure out what we got to write that OR. Now, of course, what our goal is to find out is if it's independent, if it's mutually exclusive, or if it's dependent. Okay? So let's review that real quick. We know that it will be mutually exclusive if the probability of A and B is equal to 0. We know that it'll be independent if the probability of A and B is equal to probability of A times the probability of B. Now, if it's neither one of those, then it's just dependent. Okay? So those are the specific cases. If it ain't specific, then it's dependent. All right, so let's get going. God bless it. Every time I do that, stop doing that. All right, let's go back to this question. So I got an OR. So you don't have a choice but to write the OR formula. Let me just get my pen ready. So we're going to write the probability, I haven't written on here in a while, of A or B is equal to the probability of, I should be doing capitals, huh? A plus the probability of B minus the probability of A and B. Now this thing here, this is the decision maker. Again, if it equals 0, mutually exclusive. If it passes the test, it's independent. All right, so that's the one we're going to be looking at. And I hate this pen, so I'm going to get rid of it. So let's try green. So we were told that the probability of this is 0.88. Is equal to the probability of A, which is 0.25, plus the probability of B, which is 0.84. Hopefully you made those changes. Minus the probability of A and B. So these two things are both positive, and they need to go over there. So I'm going to bring my calculator up. 0.88 minus 0.25 minus 0.84. Bam. Negative 0.21. So I end up with negative 0.21 is equal to the probability of A and B. Well, actually, it's equal to negative probably, right? So the negative here. All right, again, like we said in class, we don't need these negatives, so we'll just make them positive. So since this here did not equal 0, it's not equal to 0, we know it's not mutually exclusive. So the only thing we have to do now is test to see if it's independent. So we're going to test to see if it's independent off to the side. Now remember, for it to be independent, this here has to be true. So we're going to see if that's true. If that's true, it's independent. All right. So we're going to write the probability of A and B. Does it equal the probability of A times the probability of B? It's a question. So what we got is 0.21 is equal to 0.25 times 0.84. We're just making the test. And what we end up with is 0.21 equals, so 0.25 times 0.84, 0.21. So events A and B are independent. All right, let's move on. So we're going to do that same thing 2 more times. So we're going to write down the equation. Probability of A or B is equal to the probability of A. God bless it. We keep hitting that button. A plus the probability of B minus the probability of A and B. Again, this thing here at the end is going to dictate stuff. So 0.83 is equal to 0.62 plus 0.21 minus the probability of A and B. So again, these two things are going to go over to the other side. So 0.83 minus 0.62 minus 0.21. Oh, goose egg. So I get 0 is equal to the probability of A and B. Well, if I remember correctly, if I get probability of A and B equal to 0, that means they are mutually exclusive. So I come back over to here and I say events A and B are mutually exclusive. All right, we got one last one. Anyone want to guess what this one's going to be? I'm thinking dependent, but who knows? Let's check. So, again, we got an OR. So we're going to start with the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. Man, that was big. So 0.78 is equal to 0.38 plus 0.55 minus the probability of A and B. So again, these two things are going over to the other side. So we'll come over here and we'll go 0.78 minus 0.55 minus 0.38. Negative 0.15. So negative 0.15 equals negative probability of A and B. Don't need the negatives. In fact, if you want, just erase them. So I know it's not mutually exclusive because it's not equal to 0. So I have to make that test that we made just a few minutes ago. I got to do that same exact test. I have to test, does the probability of A and B equal the probability of A times the probability of B? Well, we came up with 0.15 for this. Does that equal 0.38 times 0.55? And I get 0.15 equals 0.38 times 0.55, 0.209. So since it does not equal, we know that events A and B are dependent. So to recap, if the events turn out to be equal like this, and it passes the independence test, they're independent. If it turns out to be equal to 0, then the events are mutually exclusive. And if it isn't equal and they're not 0, then they are dependent events. That's that. That's problem 1. All right, that last question was long. Let's talk about this one. So here's how you should deal with this one. Okay, we got a whole paragraph going on here. You can read it once, read it through. I'm sure you have. Hopefully you have. If you haven't, pause it to read it. But then I'm going to go through and read all the pertinent information. We know that there are 53 quarterbacks. We know there are 28 that played for one team. And we know that there are 63 that played quarterbacks or one team. Now, do you see the or? That or means we're going to end up writing that or formula. You don't have a choice. You go back to the flow chart. What's it say on the flow chart? It says, does it have an or? Yep. Okay, then we got to go this direction. Stop. So, first thing first, though, we're going to pull out information. The probability of quarterback is, there are 53 of them, so it is 53 over 318. There were 318 people in the Hall of Fame. The probability of playing for one team, if you just want to call it T for team, I don't care. I called it one team. Looks like it. One team. That's 28 out of 318. And now the probability of playing for quarterback or for one team is equal to 63 out of 318. All right, because of this or, this is the big word in the question, and this or right here, we have to write the or formula. So that's what we're going to do right now. The probability of A or B. We can't use A or B. That doesn't make any sense. Use Q and 1T. So the probability of, I know that's automatic to do, but don't do it. Q or 1T. Looks like quit, huh? Make it look like 1T. Is equal to the probability of Q plus the probability of one team. T would have been easier on that one. Minus the probability of quarterback and one team. And the question says, what is the question, by the way? The question says, picked at random is both a quarterback and played for one team. So what I'm looking for is this. Ultimately, I got to find this. That's what I'm looking for. So everything else I probably know. So this is 63 out of 318 equals 53 out of 318 minus 28 out of 318 minus, they should be plus, by the way, plus the probability of Q and one team. Well, these two things need to go over there. And since the denominators are the same, I can simply just subtract the numerators. If you want to do it, it's a kind of a pain in the neck. If you want to do it this way, you can certainly do it this way. Let me get rid of all this crap. You can do control division. What is it? 63 over 318. And then we're going to subtract off 53 divided by 318 minus 28 divided by 318. It'll fix it, make it look all pretty for you. But look, we're just going to subtract those off. It gives it to you in its reduced form. If you wanted to, you could just do 63 minus 53 minus 28, and you get negative 18. So the answer is negative 18 over 318, which, if you reduced it, was negative. That is a weird, I don't know how that reduces to negative 5 over 106. No, that's not even right. Oh, this should be 28. I know that was negative 5. Negative 3 over 53. It reduces to negative 3 over 53. If you reduce it, doesn't matter. Is equal to negative probability of Q and one team. Don't need the negatives, so we can just get rid of them if we want. There's your answer. So you can either have this answer, which I kind of like because it's out of 318, or you can have this reduced answer. It makes no difference. I must tell you, it's kind of depressing not to have my coffee right now. I'm a little irritated. All right, let's see what we got here. If you read through this problem, read through this problem. Now, I gave you a bunch of places to do. I gave you a spot up here to do some work. This is your thinking area. So the probability of a prep course, let's call it C for course, is equal to 0.285. Notice I took this and turned it into a decimal. The probability of studying alone or on your own is 0.183. And the probability they studied on their own and, and 13.5% said they took a prep course and studied on their own. So course and study is equal to 0.135. Now, I'm going to look through this, but I'm pretty sure there's no or in this entire problem. None whatsoever. So if I go to my spreadsheet, my flow chart, come over here to my flow chart. My flow chart says, does it have an or in it? Nope. Oh, check for independence. All right, let's look through that problem. No independence. Okay. No independence. Okay. Oh, I got to use one of these formulas over here. Oops, they kind of got cut off. Sorry about that. This should say. All right. So I'm going to do that, but I'm not going to use A and B because that's sort of useless. So, and the question here says, what is the probability that a student chosen at random took a prep course given they studied on their own? So the probability of prep given they studied on their own. Oh, I shouldn't be calling it P, right? We call it C. So prep course or prep class. All right, that's what I'm looking for. All right, so I need to write those formulas down. So I'm going to write the probability of course and study is equal to the probability of study times the probability of course given study. Or I can use the probability of, let me do it a different color for you. Or I can use, bring this up too, so it's not behind my big old bald head. Come on, move. So, or I can use the probability of course and study is equal to the probability of course times the probability of study given course. Remember, these two things have to be opposite. These two things have to be opposite. Okay, so since this is what I'm looking for, and I see it right here, I'm probably going to use this formula. Now, okay, how am I going to use that? Well, I know this. That goes here. I know the probability of studying. That goes here. Times the probability of course given studied. So I didn't need this one. I just divide by 0.183. Come over to my calculator. Shoot. I hate when it does that. 0.135 divided by 0.183. Shabam. 0.7377. So be careful here. You get 0.7377049 equals the probability of C given S. Well, the problem says to the nearest tenth of a percent. So I got to turn this thing back into percent, multiply by 100, and then round to the nearest tenth of a percent. Well, that's right here, right? That's right here at this 7, right? So I'm going to change that 7 to an 8, so 73.8%. So the probability of C given S is equal to 73.8%. Hopefully that's not behind my big head. All right, now I'm not going to scroll up too much because this one asks, based on that same information, to find the probability of studying given they took the prep course. Oh, well now I'm going to use this equation because now I'm looking for this. So let's plug those numbers in. This is going to be the probability of, so the probability of course and study is still 0.135. The probability of class, I'm not sure what that one is. What's that one? 0.285. Times the probability of study given class. Well, divide by 0.285. times 100. So I get 47 point, and I got to see, am I going to move this one? Am I going to move this number right here? Yep, I'm going to make it 4. So 47.4. So my answer is 47.4% equals the probability of study given taking the class. That's it. It's all she wrote. All right, that one's done. So Miss Leach and Miss Heatmiser interviewed 2,000 students. I'll put that 2,000 in right here. And I'm going to start filling in this chart really quickly. So I'm going to actually pause this and I'll be right back. I'm going to have it filled in when I come back. All right, if you just kept going, you would have found out you got all these numbers. Check your numbers. I make sure, add up all these to make sure you get 2,000. Add up all those to make sure you get 2,000. Should be pretty good. So to complete the table. So the question says, what is the probability that it's an upperclassman? So since there are no restrictions, no givens, the 2,000 is going to be the denominator. So now I'm going to go upperclassman. Now be careful. This is upper. This is under. So upperclassman is this number right here, 1367. So 1367. That's upperclassman. What is the probability of a medium vaping awareness? Well, medium vaping awareness is right here. So that's 956. So that's 956, no restrictions, over 2,000. Is an upperclassman and has low level awareness. So upperclassman, I'm going to highlight this in blue. Upperclassman and low level awareness. All right, would you all agree that's this one right here? 83 out of 2,000. Now these next two have givens in them. So if they have got givens, you have to figure out what that is. So they have high level, given, underclassmen. So again, I'm only allowed to look at under... What the hell just happened? I don't know what just happened. So I've got to get back into here. So let me get rid of this. All right, so given underclassmen. Be careful. You're only allowed to look at underclassmen. This is it. All the other numbers don't exist. So let me just black those out. You can't see this. None of those numbers exist. So the total, 633. So what's the probability that their high level of vaping given their underclassmen? So that would be 132 out of 633. So 132 out of 633, I believe. All right, so let me get rid of that then. I'm going to put this 0 back and this 8. So now the next question says, what is the probability they're an upperclassman given they have a medium level? So now we want to look at medium level. So that's our given. Gosh, stop doing that. Medium level. All right, so we're only going to look at medium level now. So this is medium level. So my denominator is 956. And upperclassmen would be 575. And finally, the last one has an OR in it. Well, you don't have a choice. You have to write the OR formula. So probability of under, UD, I'm going to use that for under, or high is equal to the probability of under plus the probability of high minus the probability of an underclassman and high. All right. Since this is what we're looking for, we don't know this. Under or high is equal to. Now, the probability of an underclassman is 633 out of 2,000. 633 out of 2,000. Plus the probability of high is 841 out of 2,000. minus the probability of underclassmen and high. I believe we already did this one before. Maybe not. Nope. Underclassmen and high, 132 out of 2,000. Notice none of the denominators changed because it wasn't asking about given, like given this particular group of people or given this particular group of people. It wasn't that way. So that's all I got to do. I got to put that crap in my calculator. So I come over to the old calculator. 633 divided by 2,000 plus 841 divided by 2,000 minus 132 divided by 2,123. Now this will give you the reduced form, 671 over 1,000. So the probability of U, D, or H is 671 over 1,000. Now if you did this problem, you probably got 1342 over 2,000. And what you probably did was just subtract the numerators. 633 plus 841 minus 132, 1342 over 2,000. Either way, it's fine. All right, that's that problem. Are you awake? Ha ha! Scared ya! Sorry about that. I'm sorry. I'll whisper from now on. Scared ya? All right, here we go. Let's see what we got here. Again, gave you some space for some work. I know you probably just like want to yell at me right now. I bet you do. Omalak, I know you're yelling at me. All right, here we go. Probability of player runs 10 miles, blah, blah, blah. So probability of 10. Probability of 10 miles. 0.7. The probability of starter, or right there it is. There's our little word. Remember, it's not so little on here though, is it? Or. So the probability of starter or runs 10 miles is equal to 0.88. Now, we've got two questions. Think about these as being totally separate questions. They have nothing to do with each other than we're going to use the same information. What is the probability of this starter if the two events are independent? So we want to find the probability of starter under two different circumstances. If they're mutually exclusive, which is the easy case, or independent, which is the little bit more tricky case. So, because we have the or, you don't have a choice. Get it? No choice. By the way, you like my $2,700 worth of teeth? Pretty cool, huh? $2,700 for teeth. Are you kidding me? All right, whatever. So, probability of S or 10 is equal to the probability of S plus the probability of 10 minus the probability of S and 10. All right. Because they said they're mutually exclusive, come back to my flow chart. Here we go. Do we have an or? Yes, we do. Did we write this formula down? You doggone better have. Now, independent or mutually exclusive? Oh, mutually exclusive? That means this. So, go back to my sheet, and I know, oh, that's just 0. I don't need it anymore. Oh, okay, so 0.88 equals 0.7 plus probability of 10. Is this it? I subtract 0.7, and I get 0.18 is equal to the probability of being a starter. Got an 18% chance of being a starter. Okay, that's that. Now let's do this one. Probability of starter or 10 is equal to the probability of starter plus the probability of 10 minus the probability of starter and 10. So I know the probability of starter or 10 is 0.88. I know the probability of 10 is 0.7. This is what I'm looking for because that's the question that's being asked is what is that thing? So I have to somehow know this. Let's go back over to our flow chart. And now it's saying, oh, wait a second. They're independent. They're independent. So that means I got to use this idea. I can replace the probability of A and B with that. So I'm going to get rid of this. And I'm going to replace that with the probability of A times the probability of starter. Now, I shouldn't be using A. That's annoying. Probability of 10 times the probability of starter. Or probability of starter times probability of 10. It doesn't matter. But I do know that the probability of 10 is 0.7. And then we're going to multiply that by the probability of starter. Now, we're almost done. I'm going to subtract this over. So I get 0.18 equals. Now, here's where the tricky stuff lies. This is 1 probability of starter minus 0.7 probability of starter. 1 minus 0.7 is 0.3 probability of starter. Oh, okay, so I divide by 0.3. And I get 0.6 equals the probability of starter. All right, notice I get two different answers depending on whether or not they're mutually exclusive or independent. All right, kids, buckle up. Last one's tricky. All right, kiddos, this is the bad one. This is crazy. Now, I'm going to tell you this. It's a very doable, not very difficult problem, except for the setup. But that's kind of true with all these problems, right? The setup's kind of tricky, and then once you get through the problem, it's not so bad. So bear with me. It's only notation that's going to mess you up on this one, so pay attention. All right, here we go. Again, I got space to put my work. So what do we got here? Found that 23% exercised their right to vote. So the probability of voting is equal to 0.23. Found that 75% voted given they took a class in civic duty. So probability of voted given they took a class in civic duty was 0.75. They also determined, now this is one of the hard parts right here, that 60% did not vote and did not take a course in civics. Now here's where the hard part goes. I'm going to put this one in a different color. This is the probability of not voting. In other words, voting complement, not voting. And not taking the civics course, civics complement, is equal to 0.6. And I'll put the last one back in red. It says the probability that he took a civics course is equal to 0.66. Now, if you can get over the weird notation of this problem is not going to be that bad. Okay. So nowhere do I see an or. Nowhere do I see an or. Okay. That's kind of cool. We don't even have to worry about that long, crazy formula. We're not even on that side. We're over here. No or. So we're over here. Now, did I see independent? No. Well, that means that I am going to live in this area right here. These are going to be my formulas that I have to use for this one. Now, you're not going to use A and B. We're going to use civics and voting. So let's go back. What is the probability a student chosen did not vote in the presidential election? You don't get any easier than this. This is the probability of voting complement. In other words, not voting. And if you remember correctly, complement is 1 minus the probability they did vote, or 1 minus 0.23. which is equal to 0.77. So the probability of not voting is 0.77. That's it. That part was easy. The next one's not so bad either. This is what's the probability of a student chosen at random voted and took a course in civics. So I want the probability of voted and took a course in civics. Now, you can't just multiply these two things together because they're not independent events. If they were independent events, I would just take those two things and multiply them together and do them. You can't just randomly multiply things together. It just doesn't work that way. So since they're not independent events, and I told you a few minutes ago, we're going to be living in this area down here, we got to use one of those two formulas. So I'm going to write them both down. Probability in voting times the probability in voting. Oops, not voting. Remember, they got to be different. Civics giving voting. Or I could use this formula. The probability of voting and civics is equal to the probability of civics times the probability of voting given civics. Now, how do you know which one you're going to use? Well, that's actually relatively simple. Knowing that you're going to use those, that's the tricky part. Knowing which ones to use, that's pretty simple. Let me highlight the stuff we know. We know the probability of voting, bad color, probability of voting, we know that. We know the probability of civics. We know that. We also know the probability of voting given civics. Guess who wins? You are the big winner. That's the formula we got to use. So the probability of voting and civics is equal to, what's this? 0.66 times the probability of voting given civics, 0.75. See, once you get the right formula, the math is pretty easy. 0.495. All right, kid, the last problem. It says using your answer from part A, so we're going to use this probability of voting complement equals 0.77 somewhere in this problem. So it says, what's the probability they did not take a course? Oh, here we go. This one's problematic. So what's the probability they did not take a course in civics? So the probability of not taking a course in civics or civics complements, given they did not vote, voting complement. So we need a formula with that in it. Well, again, it's going to be one of these formulas right here. We just got to do it the right way. So the probability of voting complement and civics complement. Again, remember, the left side of this equation are the ands. So whichever way I write this, I'm going to do it both ways, is equal to the probability of voting complement times the probability of civics complement given voting complement. Now, if that turned out to not be correct, for example, if you did this one, probability of voting complement and civics complement is equal to the probability of civics complement times the probability of voting complement given civics complement. If you did that one, you'd find out, okay, I don't have any of this information or almost none of this information. Not only that, it said using your answer from part A. So my answer from part A is this. So I'm going to use this. And I believe we've got one piece of information we haven't used yet, and that's the probability of civics complement and voting complement. We know this. So very easy to find that. Now we have it set up. It's pretty easy. This was, I believe, 0.66. Nope, just 0.6. So 0.6 is equal to 0.77 times the probability of civics complement given voting complement. All right, I just got to divide. So the probability of civics complement given voting complement is equal to 0.6 divided by 0.77. This turns out to be a really weird question. 0.77922. 0.77922. Good enough. It's like really weird that it's almost the other one. All right, that's it. That's all she wrote, kids. That's the answers. All right, I'm going to have one more. We're going to have the same review the day before the test. Now, we're going to be going over all these questions. I suggest you get there early. All right, kids, keep studying. Good luck. Get this flow chart down, okay? This flow chart is going to be ginormous that you understand it. It will not be given to you. Don't think you're coming in and say, oh, Mr. Cross is going to pick this up for me and give it to me. No, he's not. So, bye, kids. Good luck. No, really, goodbye.